ReasonConf is brought to you by our gold sponsors Ahrefs and Chain Street.
Hey, yes, so my name's Matt Bray. I also work with Amandra, as Dave was talking earlier, but this is going to be a talk about just a library in OCaml and BuckleScript that we're using, not to do with our company. Yeah, I'm Matt J. Bray on Twitter and GitHub. Not quite as cool as Action Shrimp, but it works for me. Cool, so yeah, this is what I'm going to talk about, which I've named Decoders. It doesn't mean much, but it's kind of inspired from Elm, and it's about decoding JSON into your custom domain types. So yeah, you can find it on GitHub. It's on OPAM, and it's also on NPM as BS Decoders. So I'll tell you a bit about what it is and why did you care about this. Okay, so you have your. Can we read this? Is that okay? Cool. More. Is that getting bigger, or did it stay the same? Cool. All right, so you got your program. It's running in OCaml. It might be running in the front end in JavaScript, BuckleScript. What do? We normally get JSON as a string from somewhere. You're going to read it from this file system. You get over a network connection through your WebSocket or whatever. So here we have 1 as a string. So the second step you need to do is parse it into like a JSON data type using a library provided by whatever you're using. So here I'm using YoJSON, which is a common JSON parsing library in OCaml. And sorry, this is all OCaml syntax. I didn't have time to convert it to Reason. But so yeah, step 1, get your JSON as a string. Step 2, parse it into some type provided by a library. And then step 3 is what this library is focused around, which is like once you have your JSON type, you want to convert it into something that's useful for your program domain. You have some like custom types. That's what we love to do. We like to model our domain as types, and we need to get this data into the right format. So what you would do naively is you can pattern match on this type. So YoJSON comes with some variants. You can sort of, we want it to be an int. So if it's an int, we're going to say, OK, grab me that int. If it's not an int, then we raise some kind of error. In this case, I'm using a result type. So we put that over there, and we see that, yeah, we get OK1. Big deal. So there's a few different ways. Like, obviously, doing it like this by hand is quite time-consuming, kind of difficult. There's some different mechanisms you can do to improve this. I thought something Jerome mentioned yesterday is, yeah, we can use like PPX, so we can have a type. We can annotate it with deriving JSON. And this is really cool, really convenient, keeps your code size small. Like, you don't have to think about it, you just do it. And this is great when you control like both the consumer and the producer of the JSON. But sometimes we need a bit more control. Like maybe you're interfacing with a third-party library. It doesn't map very well to your OCaml variant types, or they have some crazy JSON conventions they're using in their API. You can kind of get around this with PPX, and they provide different deriving mechanisms, provide different annotations. You can say I want it to be in camel case, but it's actually in snake case. Type is a keyword, so I need to re-alias it as something. So that's kind of annoying. And also, when you have like large JSON structures, these PPX things, I sometimes find like the errors aren't great. When you get a problem, it might tell you which thing it was trying to decode at the time, but you don't kind of get much context. Maybe I'm just using the wrong ones. So the second thing I've tried to do with this library is like report nice errors when you're parsing these JSONs. And kind of the third reason for this library's existence is that we want to write kind of common types. So at aesthetic integration, at Amandra, we have OCaml on the back end and native, and we use Reason and BuckleScript and React in the front end. We want to kind of have shared types. We want to have shared decoders so that we can easily pass JSON around wherever we want. So the third thing that this library addresses is like how can we write these once and share them between both things? So I'm just going to give a quick kind of intro to this. So here we're using Decoders YoJSON, so it comes in different flavors. There are different libraries in OCaml. You've got YoJSON, you've got EasyJSON. Sometimes you're interfacing between them all. And this also allows you to write like one decoder and then like instantiate it on any of these underlying libraries. So here we're using just YoJSON's basic variant. I'm going to install a pretty printer so we get nice errors in the top level. Okay, so we have this JSON. If you remember from the beginning, it's just one. It's pretty advanced stuff. And this is how you call this library. So there's a function called decode value. You pass to it the JSON that you're going to decode as a value. And you have this thing in the middle, which is a decoder. So this tells you, how do I decode the type that I want? So it provides some primitives. There's one called int. So if we look at the type signature of this function, decode value, it takes a thing that can decode A's, and it takes a JSON value. This is just going to be a JSON.basic. And it gives you back a result, which is either going to be the thing you wanted or some kind of error. Simple stuff so far. Yeah, so we can run that, and again, we get our OK1. So the cool thing about this is you can start building up these combinators into your type. Actually, first I'll just show you what happens if we ask for an int, but it's actually hello. Okay, now we get an error. It says, expected an int, we got hello. So what about a list of ints? So here I'm decoding 1, 2, 3 from JSON. I skipped another thing as well. There's a convenience thing called decode string, which also calls the parser underlying it. So we decode this string as a list of ints. And we get, sorry, I jumped a bit. Yeah, okay, 1, 2, 3. Cool, so what happens if we haven't got a list of ints? There's actually something else snuck in there without us noticing. And in this case, yeah, it says, okay, we got an error while decoding this list in the second element, counting from 0. Expected an int, we got true. So that's kind of the basics. It hasn't really shown you why you want to use it yet. We can do more complex stuff. Okay, so say we got user types. There's a field name, and it's a string. We want to deserialize it into our own custom type user. It has a name, and someone's left a comment here saying, oh, it has to be capitalized, otherwise all our users are in lowercase, and they don't like that. So what we want to do now is write the decoder, the thing that fits in the middle of this decode string function, that will take some JSON and turn it into a user type. So here we're saying, okay, we want an object with a field name, and the name is a string, right? But then once we decoded that, we want to then modify this string value. So we call this and then combinator, which can pass a function which gives you the value that's been decoded so far. So here we're getting the name, we want to capitalize it, and then we return the user. So we want this decoder will succeed with this user that we've just decoded. So let me whack that in. Cool, so we got OK. And Matt is capitalized as we wanted. So this and then stuff, I want to avoid any scary M words, but basically you can write it like this, but what will happen is OCaml will indent it, or Reason will indent it more and more to the right as we add more and thens. So there's a kind of convenient operator we can use, which is this guy. Some of you may recognize him. And then what we can do is we can have lots of fields, and we can just propagate the values, and then we can do whatever we want in the succeed. Cool, so what about something a bit more complicated? And this is where this library becomes more useful. So say we're operating with an API that gives us a list of shapes. The thing is, each shape is different JSON, right? And if we have a list of stuff in OCaml or Reason, it all has to be the same type. So we can have squares with the side length. We can have circles that have a radius. We can have triangles, which have a base and a height. And I've decided that for my program, I want to represent shapes as this variant type. So you can have squares, you can have circles, or triangles. So how do we go about decoding this? Right, so what I'm going to do is build a kind of sub-decoder for each type of my shape. So first of all, we decode squares. That's fine, I just get the side field. It's an integer. And then I succeed with square. And then circles are the same, so radius. Triangles, we have a base and a height. So this is where I explained about we could use and then here, but then it would be kind of nested. It's just an indentation thing. Yeah, so we get the base field and the height field, and then we get a triangle. Great. Okay, so to put it all together, we want to decode each element of this list as a shape. So what we're going to do is look at this shape field. So conveniently, oops. The providers of this API have nicely given me a shape field which has the type of the shape in it. So that's nice. I can just go, all right, to decode a shape, I want to get that field. The shape field is a string. And then I'm going to pattern match on that string and say, okay, if it's a square, then dispatch to the square decoder. If it's a circle, it's a circle. If it's a triangle, dispatch to triangle. And then to sum it all up, I want to decode a string, which is a list of shapes. So let me just whack this through UTOP. Aha. So it's saying, actually, we got an error. So while decoding this list, in the second element of the list, we expected a shape, but we got this thing. So what's here? So, we've got a typo in our JSON. So it says triangle, which is not a shape I'm aware of. Let's fix that. Rerun our shape. Great. So we got our list of shapes. So this is kind of where this library is useful when you're dealing with JSON that doesn't conform to the PPX. Like, so the PPX might represent this variant as kind of a list of lists or an array of arrays where like the first item in the array is the type of the variant and the second item is the first argument of the variant. So that's cool if you're just in BuckleScript land. It doesn't always work for other stuff. Okay, so what if they didn't give us this handy shape field which tells us what type of shape we're looking at right now? So in this case, we just got squares are represented like with a side, circles have a radius, triangles have a base and a height, but it doesn't really tell us anything else. And what we can do in this case is just say, all right, just try each of our decoders in turn. It's unambiguous in this case, like if it has a square field, then it's a square. So we can just say, okay, try using this one-of combinator. We can give it a list of decoders to try in turn, and it will just return the first one that works. Oops. So I'll put that string in. We've got this too, and yeah, we get the right answer. Cool. So that's kind of the first and second points. So the first point of this library is we want more control about how to decode up in an easy way. The second point is we want to get nice errors that like tell us as we're developing this thing, like where's it gone wrong. And the third point I mentioned was we want to be able to share these things between OCaml and BuckleScript. So okay, new domain. We have users. They have a role. They can be an admin, might be a super admin, or they can be an ordinary user. And then our user has a name and actually a list of roles, so they might have multiple roles. Okay. So these are types that we want to share between BuckleScript, Reason, and our native OCaml backend. So I'm not going to show you how you set that up, but if you're interested, like come and talk to me, and I'll tell you how we're doing it, and then you can tell me how to do it better, please. So yeah, that we shared. And then this module will also be shared. So here, what we're doing here is creating a module for decoding these types. And it's a functor. So it's going to take, as a parameter, the actual implementation you're using, whether you're a native, you might use JSON or EasyJSON, or maybe a YAML library. You know, YAML and JSON are pretty much the same, so this works with both too. So you can write your decoders once, and you get JSON and YAML parsers. So I don't know if everyone knows about functors, but you know, it's simple in this case, and I'll show you how to use it. So in this case, we've got this D guy, which is going to just give us the signature. It gives us all the primitives we need to build our decoders. So how do we decode a role? Okay, well, it's just going to be represented as a string, and it's all caps, just so you know that you are an admin. So if it's an admin, then we succeed with admin, and it's not a super admin, okay? If it's the string super admin, then it's also an admin with our super flag set to true. If it's just user, then it's user. If it's something else, then we just fail. I'm not sure if I mentioned what this does before. So in these cases, well, we need to say whether you want to, this is kind of like building our own primitives, right? So we want to say, if it's one of these valid strings, then we succeed, and that gives us an OK at the end result. If it's something else, we just want to fail. So this will raise the error. And you just say, what we were trying to decode when we fail. And the library handles like figuring out where the context is, and it will give you the actual JSON that we were looking at. So you don't have to sort of capture the string and say, expected role to be, we got this thing. Like that's all handled for you. Cool, so then what's the user? We have a name, it's a string. We have a role field, which is a list of these roles we just defined. And then we just succeed and wrap those two things up into the record. Okay, so how to use this? So in native, we're going to use your JSON basic types. So we're going to alias this module D to be that. And then we kind of instantiate this module functor using that D. And we get my native decoders. And then we can use this guy as we were using stuff before. If you're in buckle script code, you would use like decoders BS, which is on NPM. So now we've got this cool world where we can have these shared types and shared decoders. So we don't like the names Alice and Bob, I heard before, so let's just change it to Janice and Todd. There you go. Cool. This can be the new one. Cool. So did I put any of that in? Just for completeness. Nice, and we got a list of users. Yeah, so if you're interested in this library, it's on GitHub by Camel Decoders, but it also works with BuckleScript. BuckleScript was a later edition, which is why it's not called something more general. And what I've walked through today is basically the README, so you can follow along there yourself. One more thing I'd like to add is that I haven't covered is that there's also helpers for encoding JSON so that you can share those too. It's slightly less of a difficult problem, but it's nice to have common code that does the same thing.